Hello and welcome to our session today on database deployments on SUSE Rancher Prime made easy with Portworx Data Services. My name is Tim Darnell and I'm the Director of Technical Marketing for Portworx by Pure Storage. We're going to talk about a few things today. We're going to cover the Portworx platform at a really quick level, talk about some of the old ways that we used to deploy databases onto Kubernetes, and then talk about some of the goals, challenges, and outcomes that we identified that caused us to create Portworx Data Services. We'll then jump into a short conversation about platform engineering and why self-service rules the world today, and then we're going to get into the meat of the session and actually teach you how to use Portworx Data Services. So, if you're not familiar with Portworx platform, we automate, protect, and unify your stateful Kubernetes workloads in your enterprise. And we do that with three main products within our portfolio. The first is Portworx Enterprise, which brings enterprise storage capabilities to your stateful workloads in Kubernetes. The second product is Portworx Backup, and that's a Kubernetes-aware and container-aware backup and data protection piece of software, similar to your standard backup capabilities you might have in a legacy environment, but we know what we're doing with containers and Kubernetes. Lastly, and what we're going to cover today is our database platform as a service, which is called Portworx Data Services. So let's look at some of the old ways that we might have deployed data services or databases on Kubernetes. The first was just simple manual lifecycle operations, generating a YAML manifest to deploy a data service. Everything was deployed and configured by hand, sometimes just by a developer, sometimes synchronously with a DBA or a developer. This meant that maintenance, upgrades, patching CVE vulnerabilities always needed a DBA and developer pair to work together in order to efficiently, if we can use that word, use stateful data services inside a Kubernetes cluster. This created some issues in terms of policy enforcement, configuration drifts. DBAs were always getting pinged by the developers saying, hey, I've got this problem, and the DBA would look at the configuration and it had drifted far from what they had agreed upon during the initial deployment of that data service or database. This created real issues around scaling in an enterprise. If you're deploying multiple data services or lots of instances of a single data service, it was really hard for the DBA to keep track of. So automation came onto the scene with database operators, and operators are how we manage lifecycle operations, of software within a Kubernetes cluster. So deployment and configurations were automated via custom resource definitions. You could have the operator handle some maintenance items, upgrades, maybe some of those patching of an image for a CVE vulnerability. And this made policy enforcement and configuration drift less of an issue, but it was really dependent on the operator. So again, as you widened the breadth of the data services that you were using in your Kubernetes cluster, this could still be an issue. And then the open source quandary comes to bear with operators, right? Which one do you choose? There's multiple out here for Postgres, as we can see. Which one's going to continue to be maintained? Which one has the features that I need? Do I get consistency across all of the operators for all of the data services that I need to use? So, this created some real challenges for platform and operations teams because, as you can see, those tasks up at the top of this slide that those teams have to take care of: deployment, observability and monitoring, scalability, data protection, data portability and migration, cloning for a dev environment to do testing. Each one of those operators may have different ways to do that. And so it just really increases the cognitive load of those teams and potentially the size of the staff when you have to deal with so many different data services that your applications require. So we identified some of these goals, challenges, and outcomes that we were hearing from customers and people that wanted to run data services on Kubernetes. And it really fell into three buckets: reliability, operational efficiency, and that developer velocity. And as you can see here in this list of pain points, it really comes down to the majority of this stuff requires manual processes. It ratchets up our complexity in an exponential manner, and the developer and application development velocity really gets reduced. So for Portworx Data Services, we identified some benefits that we could drive, like policy-driven configurations, giving a single view across the enterprise to the DBA or platform team that's responsible for managing all of the infrastructure that these data services are running on. Multi-tenancy is a big deal, especially in large enterprise organizations. And then really keying in on that one-to-many DBA to developer ratio to drive efficiency for your development and your applications. And we feel that this ends up providing you with a really reliable, resilient, and efficient way to use data services on Kubernetes, all with self-service deployment. So let's talk about why self-service rules and kind of the ties back into platform engineering. And anybody that has had to actually participate in operational, ongoing processes for a production environment really does know that the toil is real here, right? Your developers just need a database, an endpoint, and some auth info, but your DBAs and platform teams are responsible for kind of maintaining those guardrails and not letting things get out of hand with that configuration drift. So we like to say that PDS paves that golden path around data services on Kubernetes. We allow platform engineering and DBA teams to do things like only authorize data services to be deployed in a specific cluster or namespaces within that cluster. We can let the DBA enforce runtime variables to make sure that the data service is being configured and conforms with policies within your organization. Okay, so let's go ahead and take a look at how Portworx Data Services can solve some of these problems so that your developers can say, this is efficient, this is great. Why didn't we have this before? Let's jump in. Okay, so what we've got here, we've got SUSE Rancher, and we can see we've got a few clusters here. We're going to use this TimD RKE2 cluster that I've deployed. It's a completely empty cluster, and it's got Portworx Enterprise installed to be able to allow us to carve out PVCs and have persistent stateful workloads on us. Now, this is the Portworx Data Services UI, and the first thing that you're going to see is a clusters overview. And you can see that I've already got a cluster registered here, but it's not my RKE2 cluster. So if I click Connect Cluster here, the first thing we have to do is install our Portworx agent. And this is a teleport-based agent. You don't need to open any holes in your firewalls to allow the cluster or our agent to speak to the PDS control plane. Everything's done via teleport and reverse gRPC tunnels. So I'm just going to use the default manifest here. If you want to go through and take a look at what we're doing, you can take a look at that manifest. I'm just simply going to copy this manifest and come back over to my Rancher interface here. Let's fire up a kubectl shell. And then I'm just going to go ahead and paste that manifest content into a file. Let's do a VI on our manifest YAML. We'll paste this in, save the file. And so now we have this manifest for our PDS agent to go ahead and be installed. So all we need to do is just do a simple kubectl apply of that manifest, and we're going to be off and running on our agent install. Okay, you can see we've created that PX system namespace and started our bootstrapper for the agent. So what that's going to do is it's going to fire up the teleport agent and then register that back to our PDS control plane here. So we should see our cluster show up here shortly. It does take maybe a minute to minute and a half. We can see our clusters shown up. Our agent was unhealthy there for a second. And we can come in, look at the status details, and see that our agent status is healthy and the version of our agent there. Now, I'm just going to rename this cluster. We assign every cluster with a UUID, but I kind of like human readable stuff. So let's rename this to timd-rke2, which is the name of our cluster in Rancher. You'll notice that our PDS operator is not installed. And, we need to install that operator in order to be able to actually deploy data services down to the cluster that we've registered. So let's go ahead and click install for our PDS operator, and that will be sent down to our PDS agent to tell it to install the PDS operator, and we're good to go. So while that's installing, let's talk about namespaces. We really don't want developers to be able to deploy anywhere they want. So in PDS, we only allow data services deployments to specific namespaces. You can see for my timd-rke2 cluster here, we have no namespaces found, even though there are namespaces on the cluster itself. And we've got a little tooltip up here that says, hey, you need to label your namespaces you want to deploy to with this PDS equals true. So let's go ahead and come back into Rancher, and I'm just going to create a Rancher project. And we'll name this one Frank's Foods. We have some food delivery services and barbecue applications that you might have seen that we use for Portworx Enterprise. So let's go ahead and create our Portworx Frank's Foods project here in Rancher. We'll create a namespace in there called PX Barbecue, which is one of our applications. And so now we've got our target namespace in Rancher project that we want to allow developers to deploy to. So I'm going to come in and copy that kubectl label command that I need to run on that newly created namespace. We'll come back over to the Rancher interface, fire up another terminal pod here, and then I'm going to label that newly created PX Barbecue namespace with that PDS equals true label. So what this will do is it will notify our Portworx and PDS agents that, hey, I now have a namespace within this registered cluster that I'm going to allow deployment of data services to. Let's check our PDS operator. We can see our version popped up there, and we see that our operator status is healthy. So if we come back over to namespaces now, we should see our PX Barbecue namespace pop up once we set the focus to our RKE2 cluster, and there it is. Okay, so let's talk a little bit about multi-tenancy before we dig in any further. Now, the parent object in our multi-tenancy model is your PDS account, and that's what you get whenever you register for Portworx data services for your enterprise. Now, you can have organizations underneath that account, and that might map to a geographical region in your enterprise or a business unit. And within those organizations, you can register things like Kubernetes clusters, namespaces that we're allowing to deploy to. And then the lower level in our multi-tenancy model is a project. And so that's where you can actually tell it, hey, I only want you to be able to deploy to a specific Kubernetes cluster and within the specific namespaces. And then there are templates that we can provide for you to kind of limit the configuration drift that you might have. So let's take a look at this in the PDS UI. So you can see here our default PX system tenant organization, and you can see in the right-hand corner I'm logged in as an org admin right now, so you can see I'm targeted towards PX system tenant. And then if we look at projects, there's a default PX system project, and you'll notice that database deployments, clusters, and namespaces all have a wildcard there. So let's go ahead and create a project for our Frank's Foods project, and we'll name it Frank's Foods. We'll give it a little description of Portworx barbecue applications for Rancher infrastructure. Okay, so let's go to the next step and select our namespace. We could search by a label, or we could select the cluster. So we'll select that RKE2 cluster, and we'll select our PX barbecue namespace that we created and labeled with PDS equals true. So let's go ahead and create this project. And now if we go look at the projects view, we're going to see our Frank's Foods projects there with the PX system project. And if we take a look at it, we have one cluster that's available for deployment and one namespace that's available for deployment. If we dig in a little deeper, we can see we don't have any data services deployed right now. There are no backups for our data services because there's no data service deployed. We can see our PX Barbecue namespace that we are allowing deployments to. Now, resource settings, these are templates, and these are going to define, how many CPUs, memories, storage. We're also going to look at some of the data services configurations. We can see there's none of those found either. Storage options are going to tell us, what type of file system to use, how many replicas to use. We don't have any of those. And then if we look at backup schedule policies and then the target locations for those, we don't have any. So let's go ahead and assign some of those to our Frank's Foods project so that we can actually deploy some data services. We're going to start with resource settings here. And these define how many CPUs, how much memory, what size of data disk do we want. And we have some sample templates that you could copy from and then modify if you need. I'm just going to go ahead and walk you through the wizard and create a new one. So let's create this for our Postgres PX Barbecue template for a dev environment. And I'm just going to say, hey, just one CPU. I don't want it to scale above that. Now I could say, hey, allow it to burst between 1 to 2 CPUs, but I'm just going to set this to 1 since this is a dev environment. We're going to do that the same way for memory and assign 500 meg of memory per pod. And we'll just say 15 GI for a storage PVC for each instance for Postgres. So we can see that our resource setting template is there, but I need to assign it to a project. So I'm going to select it, add it to a project, and let's select our Frank's Food project and click Add to Project. So none of those other ones that you see below there will actually show up in Frank's Foods now. And if we look at the actual project, we can see that single resource setting template that we just assigned will be available for the developer to select when they deploy their data service. Next, let's look at storage options. Again, you can see there's a bunch of different configurations that are defined in that default project. Let's go ahead and create one for Frank's Foods. Now, these storage templates are going to define what type of file system do you want to use for the underlying pod. And we'll just give this a name. So let's just use the default ext4 file system. We can also tell it if we want to use the older Portworx in-tree CSI provisioner or the new out-of-tree CSI provisioner. We're just going to select the Portworx CSI provisioner. We also give you the capability to define how many replicas of that data disk for the data service do you want to deploy. Portworx Enterprise allows up to 3 replicas of a PVC. We're just going to leave this to 1 for now, but if I selected 2, then I could check this box that says Enforce Volume Group Policy, which would force the spread of those replicas across worker nodes in your Rancher cluster. We're just going to do this for a dev environment, so let's unselect that. We'll stick with 1 replica, and we'll go ahead and create that template. Now again, I need to add this to my Frank's Foods project so that the developer has a storage option template to use whenever they deploy Postgres. So let's go ahead, add this to our Frank's Foods project. And then we're going to jump into data service configurations. And these are those runtime variables or environment variables for specific databases that your DBA may want to enforce. And as you can see, we have a lot of samples up here for different databases. You can see Couchbase, Elastic, Kafka. We're just going to use one that I've previously configured for Postgres called dev Frank's Foods. And that's going to enforce the date style within Postgres to ISO date style, so we don't have that European versus US conflict that we always have. And then I'm going to set their default database to Frank's Foods, because I, as the DBA, know that that's the proper database that the developer should be developing against. Okay. I do want to show you one thing, and that's the lock template checkbox here. So this is really nice because it's a way for the DBA to enforce these configurations. And you'll see when we deploy that these will be shown but grayed out. Now, if I unchecked that box, the developer could potentially modify that key value pair, but I don't want them to do that. So let's go ahead and add this data service configuration to our Frank's Foods project, and we're good to go. The last thing I want to show you are policies around data protection. And so we can have scheduled policies for data protection and backup of our databases or data services. This one we've just said daily, every day at midnight, and I want you to retain 5 copies of that. Again, I need to add this to my Frank's Foods project so it's available for the developer to select when they deploy a data service. Now, backups are kind of useless if we don't have a target or a location for those backups to go. You can see that we've got an AWS S3 bucket registered here. So I'm just going to add that to the Frank's Food project that the schedule policy ends up using. And then we should be good to go for data protection for a deployed data service. I'll add this to our Frank's Foods project. Okay, so now if we go look at our Frank's Foods project, we can see that we have options and templates available for everything. There's our namespace, we have our CPU and memory and storage size template. We've got the data service configuration that enforces our date style and default database for Postgres. We can see the file system provisioner and replication factor policy that we've set. And then we can see the available backup schedule policy and backup location that we've allowed the developer to use whenever they are deploying Postgres. So now that we've kind of shown you what the platform engineering team or the DBA can set in terms of configuration, let's look at the data services overview. And this is a really nice view of everything that's deployed in your organization. Okay, so you can see we've got some other databases, data services deployed here, and those are all in the default PX system project. So let's go ahead and set the focus to our Frank's Foods project, and you can see we've got nothing deployed yet, right? So let's go ahead and deploy that. If we click this Deploy Data Service button over on the right-hand side, it's going to pop up with all of the data services that are possible for the developer to deploy. Today we're just going to deploy Postgres and use some of those templates that we just created. So this will drop you into a wizard. We're going to give our deployment a name. Let's call it Postgres PX Barbecue-Dev. And we're using our Frank's Foods project. Again, the only cluster that's going to show up is that cluster that we authorized to be used by Frank's Foods. And then same with the namespace. If we had registered multiple namespaces and set that PDS equals true, we would have multiple targets here, but PX Barbecue is the only thing that shows up. We're then going to select the version of Postgres that we want to deploy. And our curated images for these data services will typically allow you to select multiple versions of the data service you want to deploy. We're just going to select 16.4. The configuration area is where we can define the number of instances of this data service that we want to deploy. We'll talk a little bit about that later. We're just going to deploy one to start out with, and we're going to use that resource template of 1 CPU, 500 megs of memory, and 15 GI for the actual data disk for the Postgres instance. We can select our storage options from the templates that we've authorized for our project. Again, ext4, the Portworx provisioner, and one replica. And then you can see the service configuration here that we define. Now, since we checked that lock checkbox, you can see those are grayed out and the developer cannot modify those as part of their deployment. The final thing that I want to show you is just that backups area. And this is where we can select the schedule policy that we defined for data protection for this data service. So we default to no scheduled backup. We're just going to go ahead and select daily, and it's going to default to that location. If we had more than one backup location, you would be able to select it there. So we're set to go. We can click deploy. But before we do that, let's go back to the Rancher cluster, or the RKE2 cluster here in the Rancher interface, and let's just watch the namespace that we're going to deploy into. So let's do a watch, get all, yeah, it would help get, in the PX Barbecue namespace. And, of course, watch does not honor aliases, so let's tell it kubectl. And so we've got a watch going there. So let's come back to PDS. We will click deploy, and our deployment is off and running. Let's reset our focus to Frank's Foods. We can see our deployments now defined with PDS. We're going out from the control plane and talking down to that PDS agent. And we can see that our Postgres instance is already starting to deploy. We can see our pod there. We can see all of the services. We can see the stateful set that's defining our deployment. Everything's looking good here. So let's go back to PDS, and we should see this come up here pretty soon and everything go green once those Postgres resources come online. There we go. So let's take a look at the details here. You can see our single instance of Postgres that we've deployed. You can see over on the right-hand side the endpoints that the developer needs to use, the username and password, so that auth information for their connection strings. And it was as easy as that. So, this really gives the developer the capability to quickly and easily deploy that data service and immediately start to use it. Let's look at some of the details of what we provide to you here. Again, you can see the ports in terms of Postgres, Patroni, the SSHD ports. You can see the service configurations, storage options, and resource settings that we defined for the developer that they used whenever they deployed it. If you come to the Backups tab, obviously it's not midnight yet, so no backup has run. However, we could schedule an ad hoc backup. So let's do that right now. Let's just go ahead and create a backup that's going to take a backup of this initial state of the data service, so that if I do screw something up as the developer, I can quickly restore back to that as kind of a checkpoint. So let's get this all configured. Okay, so our backup run should be starting. We can see running there. Let's take a look at the Events tab. This is just a nice area where we can scrape the Kubernetes events for your data service deployment. You can get details there. One other nice thing is the Copilot functionality, and so this is specific to each data service that you can deploy. This does not look at your actual database or your data that you're deploying, but it's just a simple way. For example, if you don't know how to, let's just say, how do I list all tables in my Postgres DB? And so it's going to give you the actual select statement that you could run against that database to do that. So if you're not familiar with a certain data service, or your developer isn't, they can use Copilot to kind of help them along in that single interface of Portworx data services. So let's go and take a look at the backup. Looks like our backup completed. We can see that it was a full backup and it was ad hoc instead of scheduled. If you wanted to restore it, you could click that restore button on the right-hand side there, and you'd be good to go. So let's talk a little bit about scaling. We have this single instance of our Postgres database, but what if we wanted to set up HA configuration for our Postgres database? So let's go ahead and scale that up to 3. And let's just get into the Rancher interface here. I do want to show you that deployment. There's our PX Barbecue namespace. Let's just look at this from a namespace level and use the Workloads tab within Rancher to show you this. We'll shrink down our terminal here. So there's our stateful set for the Postgres database. We can see that there's 1 replica running right now. It's only set to 1 in terms of the number of replicas. So we're going to scale that to 3. So we'll click Update here. And automatically, PDS is going to start scaling our Postgres stateful set here. So we can see we're at replicas 2 of 3. We're in progress on scaling of that, and we can come over and see that we've got 1 running and 1 in its state here. So let's just wait for this to go through. We also show this in the PDS UI, so you can see that second instance that's currently in the init state. And this should just take a second to go ahead and get all of our replicas up and running. So we've got 3 running. 2 out of the 3 are in a full 2 of 2 ready state here. Yep, we're just waiting on that third instance to come back up. And since we use Patroni to scale our Postgres instances, we're probably going to see that initial pod terminate as the Patroni HA cluster comes online with multiple instances of Postgres now. So, okay, there's our termination. We can see that third pod's up and running. If we come back to PDS, we've got our second and third instances running okay, and that first one's terminating so that it can restart as part of the Patroni cluster. So let's wait for that to come fully online. There we go. Everything's healthy. So that's how easy it is to scale a data service using Portworx Data Services. All right. So let's go ahead and take a look at our Frank's Foods project. You can see here we've got all three of our instances healthy. We're deployed. Additional endpoints were set there if we wanted to connect to each one of those instances individually. So let's go ahead and just do a quick recap here around those pain points that we end up solving with Portworx Data Services. The first is reliability, right? We're going to provide you those HA data services with resilient backing storage, give you that policy-driven configuration with our curated images that we provide. We're going to provide you with that unified abstracted view across the enterprise and provide you with multi-tenancy across all of the organizations within our enterprise. And finally, we're going to handle that developer velocity issue and provide that self-service provisioning. Keep in mind that everything you saw me walk through with the UI today is available via an API call. And finally, that 1-to-many DBA to developer efficiency ratio that we really want to take care of from a platform engineering perspective. So, if you'd like to learn more about Portworx, you can visit us at our website at portworx.com. Feel free to scan this QR code, and we've got a lot of really good videos up on YouTube around PDS and some different use cases that you can look through. So, want to thank you for your time today. I hope you really enjoy the rest of your SUSECon 25 conference, and we'll talk with you soon.